last comment until the end. So let me just give you a quick overview of what's in your handout, sort of tell you where we're going. What I want to talk about today is how to read and get the most out of your soil test report. And in doing so, I want to try and explain a little bit about where those numbers come from so that when you get your soil test report back, you're somewhat less confused. But more importantly, you know the limitations of that report and can start to use that information to improve the productivity of your specific particular operation. We'll talk about how to collect a good sample, and then and then we'll walk through what a soil test report looks like. This is our old report. Some of you have seen those. Most of you have probably seen those. We have a new report. Maybe a handful of you have started to see these come to you. We'll talk about both of them, but the main example I'm going to use is the old one because I'm assuming that that's the one that you're the most familiar with. But the same information is there, and I'll show you where to find it on each report. Okay. So then we're going to talk about how the recommendations are made, right? And that's the single most important thing about a soil test report is the recommendations. Your average bright 8th grader could do a soil test, okay, and tell you an amount of phosphorus or potassium or calcium or magnesium that's in there. Some of you who are a little older remember getting under the Christmas tree chemistry sets that you could do little experiments. The soil test kits you buy from the back of the gardening catalog are basically just that. And you can do your own soil test. The question is, how much fertilizer do you put on? That's what you don't know, and that's where I don't necessarily mean me, I mean the royal we, the soil test lab and the extension service makes a recommendation to correct your fertility based on what they know about the soils in the state and how crops respond to fertilizer applications on the ground, okay? And then, so there's the top part where that top table is how we classify a soil as being low, medium, high, or excessive. And then this bottom table is just part of a much longer table where we actually make the recommendation. And we'll go through each of these in a little more detail. Okay. Then I want to talk very briefly about fertilizer analysis. I think everybody knows, but I feel compelled to say it because there's an enormous amount of confusion out there, and by people who should know better. And I'll give you a small story. In my soil fertility class, I thought, they get tired of listening to me. Let me send them to YouTube to find out how to do fertilizer calculations. They all love YouTube, right? So I go on YouTube, I figure, well, maybe I ought to screen some of these first. It's shocking how many people can do the nitrogen, but then mess up when they get to the phosphorus or the potassium. Okay, and so I just want to make a few comments about that. If there's time, I'll walk through a fertilizer calculation because I know that you all feel the way I do that a day without a little math is like a day without sunshine. So we'll just finish up there and we'll have a few questions. Okay, so that's where we're going. And so now that you've seen it, let me just remind you all, I work at a university. Every day I talk to people who have little to no interest in what I'm saying. If that's you, no need to be embarrassed. Check your messages, your Facebook. No need to hide it under the table. Pull it out. Be proud. You don't care? That's okay. That doesn't faze me at all. Okay. So the absolute most important thing you can do when you take a soil sample is to make sure that it's a good soil sample. And I'm going to try to illustrate that this way. We're at a grazing conference, and so if you imagine an acre of soil, 3 inches deep or so, that's roughly 1 million pounds, okay? Roughly. Of that, we take 0.01 pounds, so too many. This is our scoop, okay? That's how much soil we use to evaluate what you told us your field was. So if the sample you send in does not represent that field, the number you get back is going to be lousy. That's not on us. that's on you. But that's okay, because I'm going to talk you through how to make sure that the sample that you do send in best represents what you want it to, so that the number you get back is not lousy. Okay, so we take a very, very small amount. All right, and so the first step is, before you even take a step out into the field, think about dividing your area up into zones, okay? Find your zone. And so if we look over here on the left side, you're obviously not going to treat this little patch right here the same way you're going to treat this little part. It looks like there's a little creek running down through here. There's a fence line, tree line. Each of those unusual areas needs to be excluded. Okay, on the right side here, that's an obviously unusual area, right? You don't even need someone like me to tell you to don't sample that. But there are areas in your field that don't represent the bulk of what you're trying to manage. And so separate those out. Sample each of those individually. Excuse me. We are very fortunate in West Virginia that soil testing is still a free service. So if you want to send in 20 samples, one sample, the more the merrier, okay, as far as the soil test lab is concerned. So there's no reason to try and come over here and take one sample that represents this whole area and then try and interpret how you're supposed to deal with that in terms of fertilizer applications, okay? Go ahead and send in as many as you have unique areas that you want to manage separately. I love this picture. I use this in my class. This is a great example of when you look out over a large field and it's covered with grass, or it has whatever crop you're interested in, you often don't see this kind of thing going on, okay? But you have to be aware, as the person on the ground every day, that there is small-scale variability in those soils, okay? Even in grassland soils, places where you have fed extensively, whatever, you guys know your situations better, separate those out and be aware of them. Because in many cases, so let's say that this was a pile of manure that was dropped on there, that soil is going to come back with a high value every single time for as long as you and your grandkids are probably going to live, okay? You have affected this soil's fertility status in an almost permanent way, okay? And so once something happens on the ground, keep records, keep notes, so that you know in the future, after it doesn't necessarily look like that, you know still to avoid that. In class, we play the game, what happened here? Does anybody want to guess what we think? I don't know. I stole this from the internet. Right? Does anybody want to guess what happened here? Here's my theory, okay? I have a teenager now. What I'm assuming is they backed up the truck over here to the right, and they started shoveling as far, and that edge right here, that's as far as it could get, right? And then they drove away. They put the load of compost on, but it certainly didn't get mixed in. It certainly didn't get distributed out the way you hope it would be. Am I disparaging teenagers? I don't think so. All right, so what you want to do is develop a plan, a sampling plan, okay? And more important than the actual plan you pick is that you do that every single year, okay? So if you want to zigzag through your field, that's fine. If you want to zigzag up and then zigzag down, if you want to walk corner to corner, every so many steps you take a sample, great. Just do that again next time, okay? Now, I'm going to guess that most of you don't have fields with such nice sharp corners. That's not the end of the world. You just need to be a little more clever about how you walk around and sample randomly, okay? So you're going to start here. You're going to separate out into these different shaded areas, and you're going to walk around, and every 10, 20 steps, whatever you think is appropriate, I'll give you a number here in a minute, you take a sample, okay? And that becomes, sample 4 is from one of your management zones, okay? Some of you have heard about precision agriculture and grid sampling. That's great. One of the nice things about grid sampling is in West Virginia, it's cost effective because you don't pay per sample. But then the other thing you get are these nice yield maps, all right? And you can't really get these kind of maps unless you do grid sampling, unless it just happens that these are also corresponded to the management zones that you delineated before you started sampling. Okay? So just do the same thing every time, and that way the data has meaning year after year after year. Excuse me just a minute. You don't mind if I Marco Rubio, right? Okay. All right. So the important thing about the subsample that you collect is that it be uniform. Okay? Oh, shoot. I forgot my probe in the car. All right. So it's important that the soil sample that you collect be of uniform thickness down through the soil profile to the depth of rooting. Okay? We often get asked, how deep should I sample? The soil if you call them up, and you tell them what crop you have, they will give you a depth. Typically, that's to the depth of rooting. Okay? So this is the small kind of soil probe that you can get out of a garden catalog. You're going to need a trip to the chiropractor if you sample a field with that, right? So the one I left in the car is one of the tall stand-up ones. They're a little bit more expensive. If you're going to invest in one of those, I suggest you get the one with the replaceable tip. Otherwise, they get dinged up and with rocks. We have a few. Okay? And then it doesn't go down into the soil nice and uniform. Okay? If you must use a shovel, then you have to do what's depicted over here on the right. Take a hole, take a slice out of that so that you're uniformly representing the soil to the depth that you're interested in characterizing. Right? We don't want to, if you just dig with the shovel, the tendency is to get a V-shaped trough, and then you are oversampling the surface and not sampling very well the depth to depth. Okay. So then you put all of those little cores that you've taken, about 20 is a nice round number to think about. You put all those in a bucket, you mix it up, send it to us. Okay? Then you're off the hook. You can wait. You can go to Bahamas, sit in the recliner. Just wait, because then that's when we do all the work. Okay? So we are going to dry and grind, extract, and then make a recommendation. Okay? So this is where we are right here. You're waiting. And then this is when we go to work. So when you send us your sample here, in a way, we don't really care how wet it is, right? In a way, you care a little bit how wet it is because you have to pay to ship the water, unless you're giving it to your county agent who's hauling it to Morgantown. But also, we can't do anything with it until it's dry. Right? So if you send us a really soggy sample and then wonder where your results are, we're still waiting for it to dry. All right? So go ahead, let it dry a little bit if you can. Pick out the rocks. Nobody wants to ship those. We have to pick them out also. Okay. So we are right here. We're waiting. And then the soil test lab springs into work. So a soil test, in the general sense, is any chemical or physical measurement that you want to make on a soil. Okay? So if you call me up and you say, can you tell me how much lead is in my soil? I can say yes. I'm going to ask, how come you think you have lead? But yes, I can measure lead. Okay? The soil test lab could measure lead too if you ask them nicely. We don't really think of those kinds of analyses as being soil tests because that term has now sort of been appropriated by soil fertility testing. That series of elements that are plant essential, the macronutrients, in some regional cases, the micronutrients, things that affect the growing of crops is what we generally mean by a soil test. And we almost exclusively mean the chemical parts. Your soil structure or your soil texture plays an important part in your soil fertility management. We don't measure those, mostly because they're really tedious and expensive to do. Okay, but so in some parts of the world, you'll get a salinity recommendation. We don't do it here yet, but as I go to meetings around the country, you know, there's this big interest in urban gardening. So in New York, Rhode Island, those places that have kind of lost a lot of their countryside and they're starting to now plow under the inner cities, those soils are pretty contaminated, right? And so those soil test labs are more and more being asked to make a recommendation about what should or should not be planted in an abandoned lot in Brooklyn or something, right? And we tend not to make those recommendations, but some other labs do. But the most important part is not the actual number, but it's this interpretation and it's the recommendation. Okay, and that's what I want to spend, I think, will be the most time. Okay, so we focus at WVU on phosphorus, calcium, magnesium, potassium. You also get a pH and a lime requirement. You can ask, you have to pay more, but you can get micronutrients. And for specialty growers, those of you who are organic vegetable producers, part of your requirement to get organic certification is to show that your organic matter levels are increasing. But if you want to, you can get organic matter number 2. Okay, so don't look at the slide yet because I want you to think. So imagine a soil, all right? So here's our soil, and it encompasses maybe this whole wall, right? The total amount of the element that's there, okay? All of the phosphorus, all of the calcium, all of the magnesium, and all its various and glorious forms, okay? Of that total amount, a very, very small fraction, which I'm going to say is this green part, is what's plant available, okay? And I made that purposely irregular because I don't want anybody to try and put any kind of numbers on it, because we have no way of knowing what the amount of plant available nutrient is going to be over the course of the year. That doesn't matter because we don't actually have to measure this green part. What we do, what every soil test lab does, what your little soil test kit that you buy in the back of the garden catalog does, is it extracts some, okay? So here's soil extractant yellow, here's soil extractant blue. We don't care that that extractant does not pull all of the plant available nutrient. Okay? We don't care. We don't care that 2 of these extractants might overlap. We don't care that one of them is larger than the other one. All we care about is that whatever part does get extracted is in fact correlated with yield. Okay? And that's so here are some of the different extractants that are used in the east of the Mississippi, and then they all have different names, usually after a person, a famous soil scientist. Here are the states, and here's the approximate composition. Okay? The reason this is important is because if you extract with extractant yellow, and then you do the same soil, the exact same soil with extractant blue, you're going to get 2 different numbers. Okay? So what I'm saying is if you send a soil sample to WVU, you're going to get back a number based on the extractant we use. If you send it to Pennsylvania, you're going to get a different number. Who's right? Well, they're both right. Okay? The only one that makes sense is the one that is correlated to yield. Okay? And the WVU makes recommendations based on the soil test extractant that we use in our lab. Okay? So all the recommendations we make have been made on the basis of testing soils with the Malic 1 extract. Penn State Lab is a great lab. But what should come back from Penn State is the same recommendation, right? If they have the correct field data to support the recommendation for, right? So what they're assuming is that a Pennsylvania soil is going to behave the same way a West Virginia soil does. Okay? I hope I haven't muddied that up. The idea is that if you send a sample to 2 different labs, or if you use your home test kit, you're going to get as many different numbers as you send to labs. But if they are all correctly correlated and calibrated, they will all give you the same recommendation. And that's where we're going here in a minute. Okay, so what happened way in the old days, right? Even when Dr. Baker was a young man, agronomists would go into the field and they would sample soils and they would test different extractants, okay? And what they would try to do is find one, like this black line here, that was correlated with yield. That is, if your soil tested low, the yields tended to be low. If your soils tested high or optimum, the yields were high. And that was a good soil test extraction. And in the early days of agronomy, that's what they did. They went out, they tested different extractants, across the state and tried to find one that was correlated with yield. This dashed red line, that would be a terrible extractant, right? You get the same number back every time and it has absolutely no relationship to what the yield potential is for that soil. Okay, so the idea then of making a recommendation is once we have put your soil into a class, low, medium, high, very high, different states have different classifications, then we can start to do additional set of experiments to come up with a recommendation. And the concept behind a recommendation is very simple. If your soil is testing low, the probability that you're going to get a response to applying that particular is extremely high. Okay? The assumption is that all the other things that affect plant growth are constant. It rains, the bugs aren't too bad. Okay? It's managed the way it should be. Compare that to a soil that's testing high. Our recommendation for the amount of phosphorus that should go on that is going to be much lower. And the reason for that is the probability that you're going to get a response to applying that amount of fertilizer is extremely low. Right? So if you're already testing high, you're already in the optimum range, okay, if you add some, maybe you'll get an increase in yield. Probably you won't. Okay? And so that sort of rough concept is how we get to the point of making a recommendation. Okay? And so this basically the same thing. How much fertilizer you put on versus what the soil test class was. If it's low, we're going to recommend you put on a lot. If the soil test level was very high, we're going to recommend you put on a very small amount or a much smaller amount. Okay, so we're still at the step 2. You're waiting, we are working. We've dried, we've ground, we've extracted. Now comes the part where we make the recommendation. And so here's the little colored box got moved on me. It should circle the data right here. Okay. All right, so this is what your soil test report looks like. There's the county, there's who sent it in, and then this is the soil test results, this section right here, okay? So pH 4.9, this McDonald character is not doing a very good job with his soils. Soil test phosphorus number is 57, K 105, calcium 1067, magnesium 105, okay? So that is the first thing that goes on the form, so to speak, okay? We take those numbers and we flop over to this table that you have this whole table, and we find for phosphorus, potassium, calcium, magnesium where your soil test category is. And the phosphorus was 57, right? It's kind of dark now. The phosphorus was 57. That means soil test phosphorus is high. Okay? And so then if you go to back to the page you have, it says phosphorus 57, and right next to it, it says high. That's from this table right here. And we do that for each of the elements. Okay? Does that make sense? Okay, so there they are, shaded, okay? Potassium was medium, calcium was medium, magnesium was also medium. Okay, so now we go back and we put those soil test category levels there, right? Now my boxes line up. Go figure. All right, so now we know where your soil tests on our scale. And it's from that scale that we make recommendations, and that's this next table, okay? So this is, you have to read these tables correctly, this is the soil test recommendation for tall grass, hay, or pasture, okay? This table applies only to tall grass, hay, and pasture. Right? So when you fill out your form that accompanies your soil sample, you could write on there carrots. Okay? They'll get a good chuckle. But then they're going to throw it into the vegetable because we don't make recommendations for carrots. If we lived in Florida, or we lived in the Central Valley of California, we got one for carrots and cabbage and broccoli and rabe and onions and kale and radicchio and whatever else crazy kind of thing you wanted to grow, they would have a table like this. They do not transcend, you cannot swap crops between them. Okay? This table was built on lots of hard, sweaty work for tall grass, hay, and pasture. If you want a recommendation for your lawn or your garden, check lawn or garden on the box, and then the recommendation will be made from a different table. Okay? Are we all clear? So we've now got our soil test categories, which we then just find on our table. And we were high in phosphorus, medium in potassium. We're going to recommend 50 to 200 pounds of nitrogen. Right? Yes?
Would it be possible to use a table from another lab if they're using the same extraction method? So if, say, they've grown 10 acres of carrots, I could get a carrot.
Yeah. Okay, so the question was if another state had a carrot recommendation or something maybe not so obscure, okay? Could you use that same table? And the answer is no, and I'm going to get to that in a second why that doesn't work, okay? But so we don't make a nitrogen recommendation because we don't test for nitrogen, right? So since we don't know how much nitrogen is in your soil, we can't tell you how much to put on. So that's something that falls under your purview as the operator to decide, are you going to go on the low side or are you going to go on the high side, right? And there are a lot of better people in this room to advise you on what that should be than me, right? So if you're not going to spend a lot of time futzing over your crop, your pastures this year, go on the low side, right? If you're going to be there day to day, you want to get in the newspaper as the high yielder, go on the 200 side, right? But you better hope it rains. You better hope that all the other things that make crops grow fall in your favor too, right? But this is what we do recommend. We do recommend 40 for P2O5 and 120 for K2O, which was what, yes?
Is there any kind of a recommendation of what kind of yield you're expecting?
Okay. I took that off of that other slide and I should not have. What happens is on the soil test form, you tell them what your yield is, what your expected yield is. If you don't tell them, they're going to fill it in, and for tall grass, hay, and pasture, I think it's 3 to 4 tons per acre. Does somebody know? I think that's what it is. They just fill in a number for you because that's going to, in some ways, influence these two numbers too. Right? So if you're expecting above average yields, then you're going to want to go with above average nitrogen. And another couple slides down here, we're going to talk about why you might want to adjust those two numbers too. Okay? Were there other questions about? Okay. So we've got this table, we've got our data, and this is the basis for the recommendations, and then just here's where they line up, okay? I don't know if yours printed with the arrows, right? But there's the pH, 4.9, so shocking, we need lime. The magnesium was on the low side, so we're going to recommend that you use dolomitic lime or a liming material that has magnesium. The phosphorus was high, and so we're going to recommend a lowish amount of phosphorus to go on that field, roughly removal rates. All right. The potassium was medium, and so we're going to make a higher potassium recommendation. Okay. And then at the bottom here, there's something about what the yield goal was, 3 to 4 tons per acre, if you didn't specify what it was. And more importantly, it assumes that you fixed your pH. Okay? So if you're not going to lime, especially don't put on the phosphorus, and think about whether you want to be pushing the 200 pounds of nitrogen per acre. Okay? Because you're just not going to get the crop response back. Okay. All right, so this is what the new soil test forms look like. I sort of had to retype this. It's not, when I scanned it, it didn't come in very nicely, but the same amount of information, you know, when you sampled it, what the crop is, some things that you may or may not know. All right, but then the results come back to you in both numeric form, that's this first column here that says the values, the category form, this is the rating, but then also these nice things that are called dashboards, right? That gives you a graphical indication of where your soil is falling on the low, medium, high, very high, excessive levels, okay? So I want to make a couple of points about this, and that is our phosphorus was testing 57, okay? It does not matter whether it tested 57 or 77. It still goes in the high category and gets the same phosphorus recommendation. Because all we've done is put it in a class, and it's from that class that we make a recommendation. So that's why you don't get a phosphorus recommendation that comes back that says 42.5 pounds P2O5 per acre. Because it's either 40 or the next level is 80. Which then gets me to the question that came up a little bit earlier, and that is, whose soil is this for? Does this, if you sent the soil from Mingo County, would you get the same soil test recommendation if you had the same soil test values as a soil that came from the Ohio River Valley? Trick question, my favorite kind, okay? The answer is you would get the same recommendation, but those two soils are very different. And that's where you, as the producer, need to know. You need to make on-the-ground decisions about what should or should not happen with those soils. The soil test lab, we have not had the resources to make recommendations for Mingo County and Ohio County and Marshall County and Pendleton County and Mon County. Right? It's one recommendation that goes for the entire state. Does that mean all hope is lost, abandon ship? No. What it means is it's then up to you to think about what you're doing and how you're doing it. And the simplest way to address that is, okay, so our recommendation was for 40 pounds of P2O5 per acre. Take a little piece of ground, put on 60 pounds. Take a little piece of ground and put on 20 pounds. Who doesn't love an experiment? Don't raise your hand because that would just break my heart. Okay? Do a little bit of on-the-ground testing and see how your particular soil compares to what the WVU Soil Test Lab considers to be the representative state soil. Okay? And then do that a couple years. What could be grander, right? And then you will know, okay, on my particular piece of farm, okay, and it may even be one part of your farm is different than another part. On each of those areas, you will be able to start to fine-tune your recommendations. Okay? And that's the position that you want to be. That's the position you need to be if you're going to maximize your economic returns, okay? And minimize the potentials for nutrient losses, which would be a bad thing. Okay, so same kind of recommendations, same kind of suggestions on the new soil test form. Okay. All right, so I have time, right? We can do a calculation? Okay. So fertilizer calculations are so trivial, it pains me to walk through it with you, okay? But I cannot hardly live knowing that there are people out there who don't know how to do it. So the basic setup is always the same. There's a recommendation, there's an analysis, there's the area, and there's the fertilizer that's going to be required. So if you want to just do 6th grade, find the numbers, plug them in, turn the cranks, get out a number, that's fine. If you want to do dimensional analysis and see how the units cancel out, that's great. Maybe ask your junior high school kid if you have trouble there. It's a very, very straightforward calculation, okay? And it's all the more straightforward because we give you the recommendation. The analysis is on the fertilizer label. You presumably know how big your fields are. And then what you get is this green one, what you require. Okay? So it's fairly straightforward. And the nice thing is that the units that the soil test lab reports your fertilizer fertilizer needs in are the same as are on the label. Okay? The only people out there who need to know whether they have P or P2O5 are those of you who are in a nutrient management kind of situation where you're going to have to run something like the P index, keep track of how much actual phosphorus is going on your farm. All that does is add one extra tedious algebraic step there. It doesn't change the basic shape of this relationship. Okay, so the fertilizer label has something called three numbers. 19, 19, 19. Everybody loves 19. First number, %N. The second number is P2O5. The third number is K2O. Okay? I promise you with all my heart, there is not any P2O5 and there is not any K2O in that bag or in that bin or wherever you're buying that fertilizer. Guaranteed 100%. And the reason for that is if you were so unfortunate as to have P2O5 in your hand, you would do that, right? Because it will burn your hand. It is an oxide, and those are bad for skin, okay? P2O5 and K2O are relics of the old days in chemistry when we wanted to measure elements. We had to convert everything first to its oxide form and then make the determination. We don't do that anymore, but and I hear different reasons for why we can't make the switch. We are, still stuck with P2O5 and K2O is coming on the label. It makes no sense to me. It's an old thing, but we're kind of stuck with it. It's sort of like metric and English units, right? It would be so much easier if we could all just decide, yes, we're going to go metric, and then convince the whole world to go back to English. But we can't. We're kind of stuck in this nether region, and so you have to be aware of when you want P or K versus P2O5 versus K2O. But again, if all you're doing is fertilizing ground, you don't have to worry about it at all because this is what the units of the fertilizer label, and those are the same units as your recommendation. Okay. All right, and so then there's an example, and all right, so there's the 10% nitrogen, there's the 11% P2O5, and the 12% K2O. I don't know that there's such a fertilizer as 10, 11, 12, but it made it easy for me to sort of separate out the numbers, okay? So that 11 right there is this 11 right here, is this 11 right there, all right? There's our recommendation, there's the analysis, you convert it to a percent, and you convert it from a percent to a number, and that's how much fertilizer of your 10, 11, 12 is going on per acre. This is what goes into your very well-managed record-keeping system, right? You multiply that times the area, and that's how much you tell the dealer you want. Okay? All right. If you have to report in P numbers, then that is 83% phosphorus, and 44% phosphorus, and K2O is 43%. Here's the K2O one. K2O, 0.12, 0.12, 0.12, 1,000 pounds of fertilizer. You should never, ever, I tell my students this, and yet they do, you should never, ever get this flipped over. If you just think for a minute about the magnitude of the answer you get, okay? You're not going to put on 120 pounds of fertilizer and get 1,120 pounds of potassium, right? So you have to put on a lot more fertilizer than you do for the element that you're interested in, because it's only 12%. If it's not about 10 times higher, you made a mistake. That's all right. Throw that piece of paper away, start again. Okay? Do you all feel a little bit sunny having done a little bit of math? Okay. Are there questions?
Questions? I'm bringing the microphone.
Yes, Dr. Scott, you touched briefly on the pH and the importance of it. But what is the rule of thumb of what pH level, how it would raise for each ton of lime that is divided per acre.
So the question was, I don't even know where to go. The question was, how much does pH change per ton of limestone added? Is that correct? Okay. It doesn't matter. It absolutely doesn't matter because the soil test lab does not use that pH to tell what your lime requirement is. There's a separate extraction that's done, it's called a quick test, that determines how much lime needs to be added to that particular soil to bring it to the target pH. So that's already built in. So some of you who have sent samples to other labs where you've had to pay money, or maybe to another state, you'll get back a number that says buffer pH. That's the pH that's used to determine the lime requirement. I think it's foolish to report that number because it means absolutely nothing without the table that tells you how much lime to then put on. So it's already built in. Okay? And you had...
Well, my question was, you're adjusting your calculations at the end. You're either going to adjust for P or K. Well, if you do your equation and figure out how much potassium you need, well, and your potassium's higher, how do you adjust for that? I mean, you're putting on 20 ton per acre to correct your P, and then you need 60 per acre for your K, just...
Right. Okay, so I'm going to paraphrase your question, and that is, you get back a recommendation for 40 of one and 120 in another, but the fertilizer is not balanced in that way. So then what do? Dang, you just got unlucky. But your friendly fertilizer dealer would be happy to make a blend for you. Okay? You'll have to pay for it, but he'd be happy to blend it for you. There are other things you can do that you can, this year fertilize a little bit more on one, and the next time when it comes back, knock it back a little. I mean, you just kind of have to adjust that. But it does sort of get to the point that maybe 19-19-19 is not the best material to be using on an annual or every other year basis. I know that's kind of heresy for some of you, but I don't know what to say. It's not really balanced the way plants take up P and K in particular. Okay? And there are others out there. It's not like that's your only choice. Okay? Was there... Yes?
Questions?
Some of the recommendations, like through NRCS, come back that you use DAP and getting free nitrogen.
Okay.
Can you explain that to us?
I can explain that to you, but not in the time I have available. So the question was, if you have a phosphorus requirement and you put on DAP, you're getting free nitrogen. Well, you don't have to have a degree in economics to know there's nothing free. Right? So you're paying for both of those, and you're paying for both of those coming together as a group. Again, in that situation, probably best to try and find a blend that's closer to what your soil is requiring. Again, I think the fertilizer dealers do a pretty good job, or at least they could if they tried to do that, to get something that's balanced to what you need. Especially if you're in, if you're in a county that the predominant agriculture is grazing, they know, or they should know, what the balance of those nutrients should be to appeal to the broadest group of purchasers, fertilizer buyers. Okay, if they're not, push them to be. Okay. Yeah. I'm sorry, would you say the beginning of your question again?
About 20 years ago, I think we got on our soils report a percent of organic content in soils.
Okay. So it's available. So the question was, can you get an organic matter number on your soil test report? And the answer is yes, but you have to ask for it, and you have to send them, I think it's $10. Okay?
Is there
I guess I'm not the person to answer that question in terms of what product is available. I will say that if you are purchasing a liming product and it does not come with an analysis, say thanks but no thanks. Okay? And the lime, I didn't go into how lime recommendations are made, but that's based on a pure calcium carbonate equivalent. Right? So it assumes you're putting on 100% calcitic limestone. If you're putting on 95% or heaven forbid 70% or something, you have to increase the amount that you put on to account for that. But if it doesn't have an analysis, stay away from it.
Well, tested by the State Department of Agriculture.
Yeah.
They have to meet certain fineness, they have to meet a certain neutralizing capacity, which is not $50. Some people do use sometimes lines that are not tested by the department, and that's, very day. You need to have it tested into what you're going to do. And some that don't meet the neutralizing capacity can be used, but you have to put more on to do that. Other questions?
Yes. People keep asking me and I avoid it. So the question was about a veil, right? And a veil is one of those products you put on to try and inhibit part of the nitrogen cycle, right? To make nitrogen, keep more available nitrogen in your soil. Is anybody here from that company? I need to check that first. I've not seen, except from them, really good data that it works. And I mean, we just heard a thing about parasites, right? And soil microorganisms are the same. You can't hardly get rid of the darn things, right? And it doesn't matter what you do, they're going to come back. And I really do not mean to disparage them in any way. I'm not aware that they are especially effective. Tell the guy that's showing up and knocking on your door that you want to try something, let him leave you a bottle. And then there's another experiment to do. What could be better? Right? And then you get a little free product.
Other questions?
Okay, thank you.
Let's show our appreciation.